Hello students, welcome to my channel eScience, and today we are going to discuss about periodic properties of the elements. Right? Already we discussed about the classification, and today we are going to discuss about periodic properties of the elements. Right? So here we are having the different properties for the elements that we need to discuss, like atomic radius, ionization energy, electronegativity, electropositivity, metallic nature, non-metallic nature. These things are there. So that things we need to discuss now. Yeah? So let us discuss atomic radius. So atomic radius. Okay. So what is mean by atomic radius? Right. So radius in the sense what is mean by radius is a size. Atomic radius, atomic size. Simple. Atomic radius means atomic size. So here we can say it very simple. If any atom is there, which is having a two shells, suppose, so we can say the definition like the distance between, this is what nucleus, right? The distance between nucleus to valence shell electrons, the distance between nucleus to valence shell electrons, it is called as a atomic radius, right? So how can we say that? The distance between nucleus to outermost electron is called as atomic radius, right? And these atomic radius we can measure in different units. It's not like a very bigger units, I mean it's not like a large quantities, they are the very small quantities. So we are measuring them in angstroms, nanometers and picometers. Angstroms, nanometers, picometers, right? So 1 nanometer is equals to 10 power minus 9 meters, and 1 angstrom is equals to 10 power minus 10 meters, and 1 picometer is equals to 10 power minus 12 meters. Okay, so very small units. So that units we are using to measure the atomic radius. So here these atomic radius, that means radius means what? Atomic radius means distance from nucleus to valence shell electron. Here this atomic radius are of different types based on the compounds. We are having the different types of compounds, like covalent compounds, we are having metallic compounds, we are having different types of substances are there. So based on that, these radius are a different type. So let us discuss the first one, covalent radius. Covalent radius. So what is mean by covalent compound first of all? So covalent compound which is formed by the sharing of electrons in between the two atoms, right? So that is, we can say like that, if suppose any molecule is there, if a molecule is there like this, AB, a molecule name AB is there. So this is the nucleus and this is the nucleus of another atom. So the total distance you measure here, some amount of distance will be there, no? So but we need only for one atom. This is for total atoms, total molecule, that is two atoms are there, but we need for only one atom. So here we say that is the half of the distance, between the two nucleus. Half of the distance, the total distance is this much, half of the distance of two nucleus which are covalently bonded, that is half of the internuclear distance, that we can call it as the covalent radius. That is, in a covalent compound, two atoms are there, suppose the two atoms are combined, that is share the electrons, and some distance is there in between the two nucleus. That half distance we consider as for one atom and half we consider for another atom. That is half of the internuclear distance between the two atoms of covalently bonded, that we call as covalent radius. And mostly this covalent radius we can take it for only non-metals. Generally we already know most of the non-metals, they involve in the covalent compound, covalent bonding, right? So that is covalent radius is mostly suitable for non-metals, right? So that is what covalent radius, that is two atoms are covalently binded over there, covalent radius. Let us discuss one more here. If suppose the covalent radius, if we taken for a homogeneous atom, like suppose if an atom A and another atom also A is there, two atoms are similar are there, So we are taking the distance. Then you can say it as, here it could be like RA, and one more also it could be like RA, because it is a atom A only, no? So then we can take it like RA and RA. So the total distance D of atom A, that is molecule AA. So that we can say it as what? RA plus RA. So we can write it as like what? 2RA. That is total distance between the two nucleus, but we want only half of the distance, no? So then we can write it as, this is the half distance, no? So we can write it as RA is equals to total molecule distance, that is DAA by 2, right? So this is what for homogeneous atom, that is homogeneous molecule, right? If you take a different, that means you can say it as like DAB, a molecule is there, then you can say it as RA plus RB. If suppose any atom is there, any covalent compound is there, like suppose H2 is there, like H2 is there. Suppose if you can say that the total distance between the two nucleus, if you say that 0.74 angstroms, what could be the atomic radius of hydrogen? That is, this is what? D hydrogen, two hydrogens are there now. So we can make it half. So 0.74 by 2. That you can make it down. Right? So that is what? Homogeneous atom. That is, similar type of atoms are combined. Then we can say it is like that. Right? So we can say one more here. Crystal radius. So very simple. Crystal radius means, again, the distance between the two metal atoms which are placed in a crystal. The distance between the two metals. Suppose if you take a crystal like this, suppose any metals are there in that. So you are taking the two atoms. You are taking any two atoms. The distance between the two atoms which present in a metal crystal, that we can say it as crystal radius. That is, you can say it as crystal radius. Again, we can take it as half of the distance again. Two atoms are, whenever two atoms are there, we need to make it half. Right? So that is crystal radius. And one more is there here, that is van der Waals radius. What is mean by van der Waals radius? Suppose if you take any molecule or any number of molecules if are there. So if suppose a molecule is there like this, A and A are there, right? And one more molecule also is there like this, B. So here we can say it as what? The half of the distance between A and A, that we can say it as covalent radius. And again, half of the distance in between B and B also you can say it as covalent radius. So A and A is one molecule, B and B also one molecule. If you take the attraction between these two, some attraction is there, right? So now the distance between these two atoms, right, A atom and B atom, so this distance, that we can call it as the total distance, and in that if you take it half, that we can call it as van der Waals radius. That is the distance between the two non-bonded atoms. The distance between two non-bonded, you see this A is different atom, B is different atom, that is the distance between the two non-bonded atoms. It is half of the distance between the two non-bonded atoms, that we can call it as van der Waals radius. And remember here one thing, always van der Waals radius is more compared to covalent radius, and we can say it like crystal radius, then covalent radius. So this is the series we need to remember. So which is having the more radius? Van der Waals radius is more compared to crystal than compared to covalent. Right? So that is what? Atomic radius, covalent radius, the types of radius again, covalent radius, crystal radius and van der Waals radius. And one more also is there, that is ionic radius. Again same like the distance between nucleus to valence electron we are saying, no, here we can say the ion, we can say it as ion, the distance between nucleus to ion which present in the last shell, that we call as ionic radius. Ionic radius. Right? And how this can be changes in groups and periods, that we will discuss. Yes, children, till now we discussed about the atomic radius and types of atomic radius. Let us discuss now the trends of atomic radius in groups and periods. That is, in groups how it is changing, and in periods how it is changing, that we will discuss. Right? Let us say in groups, right, what happens in groups. So remember, in groups, atomic radius increases. Atomic radius increases from top to bottom. If you go from top to bottom, atomic radius increases in a group. Suppose if you take in a first group, suppose hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. If you take like this, you can find out the valence shell configurations like 1s1, 2s1, 3s1, 4s1, 5s1, 6s1 and 7s1. You see that number of shells are increasing, valence shells are increasing, that is the size increasing automatically, that is shells increasing. Only one shell, small size, number of shells increases 2, size increases 3, size increases 4, 5, 6. As long as the shells increases, the size of the atom also increases. So by this we can say in a groups atomic radius increases from top to bottom. Right? Then what about in periods? What about in a periods? So if you go from left to right, in a period, the atomic radius will be decreases. Atomic radius will be decreases. Why it is decreasing? So let us say 1 minute here. So suppose if you take the third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So we will not take the noble gases. So I am taking here sodium and chlorine, which belongs to third shell, or third period. Right? You see the configuration here, 3s1 it could be, and here it will be 3s2, 3p5. In valence shell only 1 electron, in valence shell 7 electrons are there, and totally here 11 electrons are there, here 17 electrons are there, which means 11 protons are there, here 17 protons are there. That means in the same shell, this one also having the 3 shell and chlorine also having the 3 shell, and within the same shell, sodium having the 11 protons, but chlorine having the 17 protons. More number of protons means more attraction will be there, that is protons will do attraction. So here 17 protons are attracting, here 11 protons only attracting. So who is attracting more? 17 protons attracting the more, so the size will be decreases. So from left to right, the size will be decreases. So that is the reason in groups the size increases, in periods size decreases, that is atomic radius decreases. Yeah? And one more thing also we need to remember here, always the cations and anions. So cations having the less size, than the neutral atom, and an anions are having the more size than the neutral atom. Okay, so cations having the less size, anions having the more size, because suppose if you take a cation, suppose we will take a Na+1 ion, and a neutral atom, suppose we will take Na. So you consider here Na+1 and Na, how many protons are there here? 11 protons are there. Here also 11 protons are there. Here how many electrons are there? Here 10 electrons will be there, and here electrons will be 11 electrons will be there. You see this 11 protons and 11 electrons. Okay, the balancing is over there. And here see this 11 protons are there, 10 electrons are there. That is protons are more. That means protons means they do attraction. 10 electrons are there attracting by 11 protons. That means the attraction will be more, so the atom size will be decreases, attracting to inside towards the nucleus side, right? So the size will be decreases. So here size will be less. And if you take a anion and a neutral atom, we will take a chlorine minus and a neutral. Chlorine will take. So here protons how many are there? 17 protons, and electrons 17. Sorry, Cl minus. So electrons will be 18, and here protons will be 17 and electrons will be 17. So here 17 protons, 17 electrons, that will be same amount is there, so no change is there. So here 17 protons are there, 18 electrons are there. 18 electrons are there means electrons do repulsion from the nucleus, so that means they pull outside, so the size increases of the anion, that is anions having the more size, cations having the less size compared to the neutral atom. Okay, so these things we need to remember in the point of atomic radius. Okay.